All right. Good morning or good afternoon, depending on where you're at in your day. This is my AB Calculus class. Today we're going over free response 2004, question number 4. And part A, they start by giving us the equation of this curve, and we have no idea what this curve looks like. It's probably something crazy. You could go to desmos.com and plug it in if you wanted to see, but this is not a calculator question. So part A says prove that this will basically provide us this. Basically prove this is derivative. And we're going to need this derivative for part B and C. So that they give you the answer so that you can use this for part B and C if you mess the first part up. So this is clearly implicit differentiation. And this is clearly an eraser that only works decently. Okay. So implicit differentiation, we need to take the derivative of everything, and when we take the derivative of y, we get the chain dy dx. So the derivative of x squared is 2x. The derivative here, the 2 goes to the front, making 8y, but we need the chain dy dx. On the other side, the derivative of 7 is 0, it's gone. And then here, we're doing the product rule. So first piece, 3x times the derivative of the second piece. The derivative of y is 1, but we need the chain dy dx, plus the second piece y times the derivative of the first, which is 3. All right, so from here, I want to get anything with a dy dx on one side, anything without dy dx is to the other, so I can GCF out and divide. So this already has a dy dx. I'm going to let it stay. This one has a dy dx. It's on the other side of the equal sign, so it's positive. I'm going to subtract it over to the other side. Now on this side, we already have a 3y. It's in the right spot, and here we have a 2x. We want it to get to the other side, so we subtract it. From here, we GCF out. And then we're going to divide. Now that is exactly what I want, but if all the signs were wrong, meaning if I had moved the dy dx's to this side and everything else to the other side, if all the signs were wrong, if that was a negative and that was a positive, you could divide everything by a negative and change all the signs. Okay, so that's the end of the first part. The second part says, show that there is a point P with x coordinate 3 at which the line tangent to the curve is horizontal. So ladies and gentlemen, you have some curve, and if the tangent line is horizontal, that means the slope is 0. When we say the slope is 0, we're talking about dy dx. The slope is 0. So we set dy dx equal to 0. And immediately this piece multiplies to the other side and the denominator gets destroyed. And here's where it's important to pick up on that one piece of information. In the problem, they say the x-coordinate is 3. So the x-coordinate is 3, so we're going to plug a 3 in there. If I plug a 3 in there, 2 times 3 is 6. And now solve. Add the 6 and divide by 3, and you get y is 2. Okay, so that's it. That's part B. They said find the y-coordinate of P. Now, if part C says find the value of the second derivative at the point P, does the curve have a local minimum, a local maximum, or neither, and justify your answer. Okay, so here is the basic idea. First of all, we know there's a horizontal tangent. But just because there's a horizontal tangent, meaning the slope is 0, they told us in part B there's a horizontal tangent, just because there's a horizontal tangent, we don't know if we are dealing with a maximum or a minimum. So, normally once you find when the slope is equal to 0, you would say, oh, it's f prime x, and the slope was 0 when the x-coordinate was 3. But in this problem, the x-coordinate's 3 and the y-coordinate is 2. And we'd like to go ahead and make a sign chart. Oh, it's a positive and a negative, it's a maximum, or a negative and a positive, it's a minimum. But we don't have the options here because there's an x and a y coordinate involved in the slope. How do you know what's to the left and how do you know what's to the right? Well, we can't because it's we know the x is to the left and to the right, but the y's would possibly change as well. So the sign chart doesn't work when you have both x's and y's. So we need a different strategy. Now, the second strategy is going to feel like something you've never seen before because you haven't seen it since November. But it actually is a very important topic, so I'm really hoping you're paying attention. Let's see if you remember this. Let's look at 3 scenarios where the slope is 0. Slope is 0. Slope is 0. Slope is 0. Now, notice the difference between these two. Slope is 0, but concavity is different. This one is concave down, this one is concave up. So something called the second derivative test, again we haven't really reviewed it in a long time, works like this. First of all, the slope has to equal 0. So for each one of these, the slope equals 0, the slope equals 0, and the slope equals 0. Then we just need to know something about concavity. So if we look at the first one, it's concave down. Remember, concave down would mean the second derivative is less than 0. So if the second derivative is less than 0, that means concave down, and it occurs at a point where the slope of the tangent line is 0. So the slope is 0, and it's concave down, we have to have a relative maximum. Over here, it's concave up, meaning the second derivative is greater than 0. Second derivative is greater than 0 means the graph is concave up at a point where the slope is 0, and this would create a relative minimum. And lastly, folks, that's a point of inflection. It's neither concave up nor concave down, which would mean the second derivative in a scenario like this would be equal to 0. So, we have done this. This is the second derivative test. If you can't make a sign chart, you can use the second derivative and think about concavity. Concave down, concave up, or no concavity, because it's a point of inflection. And these 3 scenarios are going to be what we're looking at here. So, in this problem, they first ask us to find the second derivative, so I'm going to find the second derivative, and it's not going to be that fun. I'm going to have to do quotient rule, but we're strong people, so let's just go ahead and see if we can do this. So we have low d high, low, d high. The derivative of the high is 3, but we get the chain dy dx minus 2. So that's low d high minus high. And I'm off the screen, I'm so sorry. D low, the derivative of this is 8 dy dx minus 3. And then all over low. So they say find the value of the second derivative at the point. Now, at the point means we don't have to replace the dy dx with all of this. But we are now going to have to plug in the point we found, which was 3, 2. So, something that's really going to help us. Because again, I'm going to replace every x with a 3 and every y with a 2. But what's going to help us is this. We already know what happens when we plug a 3 and a 2 into this. If you plug a 2 and a 3 for the x's and the y, you're going to get a 0. So that's really going to help us. I mean, how did we get the 3 and the 2 in the first place? We set this equal to 0. So we do know that when I get to this point, those are both going to become zeros. All right, your AP exam is going to be free response, so your notation needs to look pretty good. So we want to show the world what we're doing. And we're just going to show the world we're plugging in a 3, 2. Sometimes it's they'll do 3, 2, x, y, 3, 2, but just 3, 2 there will work. And again, just replacing it, and then I'm going to see what the answer is. All right. Eight, y is a 2, x is a 3, that's a 0. Y is a 2. Again, that piece is a 0. Okay. Now, this is the correct answer. We can use earn it. But the issue with that, the reason we don't want to leave it like this, is we need to know, is that a positive or a negative answer to figure out if we have a relative max or min. So we are actually going to solve further just because we need to. All right, so this is 16 minus 9, which is 7. Here we have a negative 2. I feel like I'm messing something up. If I mess something up, everybody has to be okay with me. Okay. New rule. This right here is going to be... I'm just checking my work really quick. Oh my word. I made a mistake. There's an X right there. I knew I made a small mistake. Loading high minus high. Forgot that X. Oh, and that X is incredibly important. Now that that X is in there, it's 2x, X being a 3. This is going to make this whole piece 0. Wow, that's so convenient. So this whole piece here is going to be 0, and 0 times negative 3 is just gone. Nice. Sorry, I forgot that X. So that X makes this piece 0, which just destroys all this. And over here on the other side, we get 16 minus 9, which is 7. So we get 7 squared. So at the end of the day, we get negative 14 over 49. If you want to simplify it, you can divide and get negative 7 over 2. Or negative 2 over 7. Is that off the screen? Let me just check. Oh, it's off the screen. All right. So we'll just know that's negative 2 over 7 if you wanted to simplify it. But here's the important thing. So at this point, this is our answer, which is less than 0. So I need to state that my answer is less than 0. And how does that affect things? Well, if the second derivative is less than 0, then that means that it's concave down where the slope is 0. Therefore, the final answer to part C is it is a relative max. So basically, just so you know how you'd write stuff down, you'd say you'd do all this work. You'd say the second derivative is this, which is less than 0, and the slope is 0, therefore it's a relative maximum. And they should be happy. They'll throw you the points. They want you to do well. All right, that's this video. Bye.